of the methods that has become quite popular in the last few years is subcooling. Okay, subcooling is something that you're probably going to see more and more of that method used in charging procedures. We're seeing the use of 410A and thermostatic expansion valves being used as a metering device. More so now than in the past. One reason is because they do operate much more efficient with the TXVs or TEVs. And I just said something that some people would have a controversy in their belief on that, and it's one way or the other. But TXVs, subcooling is not a bad method at all. Do you all recall about how much subcooling that you need on the liquid line, if you've gone through that? Okay, a little hint. It's hard for me to remember all these numbers and everything, but the number 10. Okay? That doesn't mean it's got to be the number 10, but if it's the number 10, we're in the ballpark. Okay? Now, what that means, if you're not familiar with subcooling, is that on our liquid line, once it's gone through the condenser, the last part of that condenser, last run or two, is going to subcool or take the sensible heat out of the liquid. Okay? This would be at saturation. If you can use a little bit of imagination, this is the condenser coil. Anything in this part is where the ambient, or excuse me, is where the latent heat is removed, or the superheat is removed. When the refrigerant first comes into the condenser, we've got to remove the superheat, and then we're going to remove the latent heat, and then we're going to subcool it. By having 10 degrees of subcooling, or some subcooling, that's going to ensure that the liquid in this line is below the boiling point, or vapor point. Metering devices, what are they designed to throttle or meter? Liquid. If I start getting vapor to it, it's not going to work right. So by having the subcooling, I have the reserve refrigerant back in the condenser in most cases. Okay? And again, the last pass or two is where that subcooling takes place. The more refrigerant I add, the more it's going to back up into the condenser. The higher the subcooling would be. Now there's a problem. If I get to the point that I don't have room enough to do the latent removal, then my head pressure is going to go out of sight. Okay? If I don't have enough subcooling, I'm going to get flash gas. That's the reason subcooling has become one of the good methods of charging. And you'll see that on the manufacturer's specifications on many units. That method does not work well with a fixed orifice system. A TEV is going to try its best to maintain what? On the evaporator.
10 degrees of superheat.
It's trying to control the superheat. You're going to get fluctuations. But its job is to control the superheat, not the pressure, the superheat. It's measuring both the temperature of the suction line or the exit of the evaporator and the pressure. And it's comparing the two and doing the superheat method. Do y'all know how to do the subcooling method? If not, let me explain. You take the pressure of the refrigerant line, in this case it would be the liquid line. Take that pressure, use your pressure temperature chart, convert that pressure to a temperature, okay? Measure the temperature of the liquid line, compare the two temperatures, the difference would be your subcooling. Okay, let's use an example, R22. If I had 210 pounds of pressure on my liquid line, I know I'm out of the picture over there, but hopefully we can make up for it. I said if I had 200, well in this case I'm going to use 213 pounds of pressure, that would tell me that my temperature would be 106 at saturation. Okay? If I want 10 degrees below that, it's going to be 96. That would give me 10 degrees of subcooling. Okay? If I only had 3 degrees of subcooling, what's that tell me I need to do? add more refrigerant. I need to back it back up into that conditioner. If I have too much, it tells me I'm probably overcharged. Okay. Again, the system has to be clean. The condenser has to be clean. If you go behind someone who has changed the fan blade or the motor, this ain't going to work too good. Okay? That happens. You know, you go down to the parts house, you need a motor that's, I don't know, let's say that it's 1100 RPM. Guy says, I don't have an 1100 RPM motor, but I tell you what I do have. I have one over here that's, let's be on the safe side and say 1500, okay? Well, that don't sound like a whole lot. But it's probably overamping the motor. Number one, we're probably moving too much air. We're doing a lot of work for nothing, is what it comes down to. It's going to affect your pressures. It's going to affect everything. In most cases, it's the other way around. In most cases, they're going to maybe go from a higher RPM motor to a lower RPM motor, and maybe only 50 or 60 RPM. It doesn't sound like a whole lot, but it will affect that system. Okay? I'm a firm believer, what come off, what the manufacturer decided that needed to be there, put it back that way. If you notice that somebody has changed something, check it out. I'm not telling you to use OEM parts, but don't just use that any part. I love what's a counterman's job? He's a salesman. If he doesn't have the right thing in there, he's going to try his best to find something that he can sell you. I'm not cutting countermen down. They do a good job. If you're in a rush situation, you may have to do that, but make sure that it will work for the application, okay? All right. Method number 3. Anybody want to guess what that's going to be?
Superheat.
You got it. Superheat. Superheat does not work well for TXV systems. It will work, but it doesn't work well because the TXV is what's controlling the superheat. But it works exceptionally well when you have a fixed orifice. Oh, I can't spell that.
Abbreviate.
Is that right?
Yep.
Okay. I got lucky. A fixed orifice system. Can you tell me what's a fixed orifice system?
A window unit.
Okay, it could be. Capillary tube? What kind of metering device? Capillary tube? Sometimes you hear them known as a disc, a piston. Y'all heard of that? Okay. Some of the brand names, Accurator. Okay. It's a fixed restriction between the high side and the low side. It could be the liquid line. The entire liquid line could be your metering device. Some companies have actually used it. But it's still a fixed orifice system. Well, what determines the capacity of a fixed orifice system? Several things, but one in particular is the pressure between the high side and low side, meaning that's what's going to determine how much refrigerant flows through that metering device. Okay? Now, you've got to think about what all can factor in as far as the pressure is concerned. What can change the pressure? Temperature can change the pressure, right? If I have a higher than normal ambient outside, or design is outside of the design, then my ambient's going to be up, of course, but my pressure's going to be up. If inside the conditioned space is too warm, then that pressure would also be up. Keep this in mind. If I raise my suction pressure, my head pressure is going to do the same thing. It's going up. If I lower my suction pressure, my head pressure is going to drop. Why is that? It doesn't have to do with the load. Okay? If I pull more heat out of the space, that means I got to push more heat away from the condensing unit, right? Okay. Pressure, temperature relation. High temperature, high pressure. Low temperature, low pressure. Okay? We'll pick right back up here in just a moment.